This video is going to cover the beginning of the test review sheet number 1. And if you notice, class, the top of this page has a list of vocabulary words that you need to know. So it'd be a good idea to practice those and make sure if you've been making mistakes on the quizzes that you correct your mistakes so you're ready for the test. I won't go over those. You can study those on your own. Alright, let's take a look at question number 1. Question number 1, show your work in the blank space or line provided and write your final answers in the box. For the function f of x equals negative 5x squared plus 2x plus 7, what are the values of a and b? So class, we need to recognize that this is a standard form quadratic. That means the a is on the squared term, the b coefficient is on the variable without a squared exponent, and the c is the constant. So in this case we have an a value of negative 5 and a b value of 2. Question number 2, for the function f of x equals 2 times x minus 5 squared plus 9, what are the values of h and k? Now on this particular quadratic we are now in vertex form. We have a binomial squared, so it's vertex form. That means the h value is inside the parentheses, the k value is outside. And remember class, when we pull h out of a vertex form we always flip the sign. We see a negative 5, that means h is positive 5. And the k value we keep, that is positive 9. It stays positive 9. Question number 3. What is the vertex of the function f of x equals negative x minus 5 squared plus 9? Looks pretty much the same as question number 2, except for the a value is different, but the same rules apply. H and k, this is vertex form. H and k, that is the vertex. So if negative 5 is in the binomial, then the x value of the vertex is h, which is 5, and the k value is the y value of the vertex, and that is 9. Question number 4. What are the x-intercepts of the function y equals x minus 3 times x minus 7? Class, this is a quadratic, and you see no square in any of the variables, on any of the variables. That means we are in intercept form, which actually tells us the intercepts. We find the intercepts by finding out what changes x minus 3 to 0 or what changes x plus 7 to 0. The reason we know that is because we know that at the x-intercepts the y value has to be 0. Y is always 0 when we have a point on the x-axis. And so either this term has to be 0, so the whole thing changes to 0, or this term has to be 0, so when multiplied by the first binomial it turns to 0. Well, in this case 3 minus 3 equals 0, so x is either 3. X plus 7 equals 0, that's going to be the opposite sign, or negative 7. So negative 7 plus 7 equals 0, so our x-intercept is negative 7. Number 5. Now we're going to go back and kind of repeat what we did before to practice. This is where you should definitely stop the video now and do 5, 6, 7, and 8 and see if you can do those on your own. Alright, let's take a look at number 5. For the function f of x equals 3x squared minus 4, what are the values of a and b? Again, class, we see there are no parentheses. This is standard form. So let's take a look. We've got our a value on the squared term. We don't have a variable term without a square. That means there's no b value, and this is our c value. So in this case a is equal to 3 and c is equal to negative 4, but our b value is 0. Number 6, for the function f of x equals negative 4 times x plus 6 squared minus 12, what are the values of h and k? Well, this is vertex form. We have a binomial squared. That means h is right here and k is right here. Remember, class, when we take the h out of the equation, we flip the sign. That means h is negative 6, and k, we keep the sign, which is negative 12. Question number 7. What is the vertex of the function f of x equals negative 4 times x plus 6 squared minus 12? Oh, that's actually the exact same function as number 6. And since this is vertex form, and we know h is the x value of our vertex, and negative 12 is our y value. So since h is negative 6, that will be the x value of our vertex. The k value is negative 12. And just so you have this in your notes, for the vertex, h and k equal the vertex x and y. So h, the value of h is the x value of the vertex, and the value of k is the y value of your vertex. All right. Number 8, what are the x-intercepts of the function y equals x plus 14 times x minus 2? Well, this is intercept form. There's no square on the variables. That means we're looking for two values of x. What is the value of x that changes x plus 14 to 0? Or what is the value of x that changes x minus 2 to 0? Either one of these binomials is 0. The whole thing on the right changes to 0 because anything multiplied by 0 is 0. And that means our y value will be 0, and that means it's an x-intercept. Well, this is negative 14. Negative 14 plus 14 equals 0. And 2 minus 2 equals 0, so 2 is our value of x. All right, a little more difficult one. Number 9. What are the x-intercepts of the function y equals 3 times x minus 2 times 2x minus 5? We're going to follow the same procedure as number 8 because this is intercept form. That means we know the x-intercepts are where either x minus 2 equals 0 or 2x minus 5 equals 0. This one's an easy one. The x equal to 2. 2 minus 2 is 0. We've got one of our x-intercepts. This one we got to do a little algebra. We're going to add 5 to both sides, and that will give us, that's going to give us 2x equals 5. Then we're going to divide both sides by 2, and now you see I'm going to write this answer over here. The 2's turn to 1. 2 over 2 is 1. That means x equals 5 over 2. Now I would accept that as an answer, 5 over 2. If you wanted to put that in your calculator, you could figure that out. That's actually going to be 2.5, so I would accept that answer as well. Question number 10, last question on this video. What are the x-intercepts of the function y equals negative 2x times x minus 2 plus 4 times x minus 2? Now class, you cannot find the x-intercepts directly yet because this actually is not intercept form. It's good that we don't have a squared variable, but you see that like number 9, we don't have two binomials in parentheses with an a value in the front. We need to convert this to intercept form, and that's pretty easy to do because this just looks like the second step of a distribution problem. We're going to take the front monomials, and those are going to get combined together. And then I'm going to take the second binomial, which was repeated, that was our common factor, and I'm going to put that here. So you can see, class, that this equation, the second one I just wrote, it's identical to the first equation. We just unsplit the first binomial. And now we can go ahead and find the x-intercepts. Either negative 2x plus 4 equals 0 or x minus 2 equals 0. Well, this one's the easy one. This value has to be 2. X is 2. This one, again, we'll do a little bit of algebra. We've got to subtract 4 from both sides because we want to move the constant to the other side. When we subtract 4 from both sides, we get negative 2x equals negative 4. And now we want to get the x by itself. Now that the term is by itself, now we can get rid of the coefficient on the x. Divide by the coefficient on x, and you will see that the negative 2 and the negative 2 change to 1, and we have x equals negative 4 over negative 2, and that is equal to 4 divided by 2, which is 2, and a negative divided by negative is a positive. So in this case, we've got two x-intercepts, and they're identical. They're both 2. So I'm going to revise my answer here. Instead of writing 2 numbers, I'm just going to write 1 number, because there's only one x-intercept, and that is at the value of 2, or that's when x equals 2. That covers questions 1 through 10 of your review sheet.